Hello, Festive Tech Calendar. My name is James Luterek, and I've been working in the tech space, specifically e-commerce, for almost 20 years. Right now, I get to work for a great company, Elastic Path. They're the pioneers of composable commerce and doing amazing things with technology and e-commerce. And we have a really fun talk, holiday themed for you today. It's called Santa's Tech Stack. So let's dive right in. Here's the situation. Santa realized that all of his magic is on the fritz. His lists aren't telling him who's naughty and nice. His, fulfillment is not set up correctly, and all of the magic is just kind of gone. And he's hoping that technology can help with saving Christmas and making sure all of his Christmas Eve deliveries get out on time. But don't worry, we're not alone. In order to help, we have access to his massive team of elves, and they're master builders. They can build toys, they can build electronics, they can build anything we need them to build. And so they're going to help us in creating this awesome tech stack to save Christmas. So let's look at the requirements a little bit. We need to track all of the naughty and nice behaviors. We need to allow people to send in a list of toys that they might want, their wish lists. We need to have a list of all the possible toys and gifts that people can get and keep track of how many gifts have been built by the elves and are ready to go. We also need to keep track of all the deliveries that take place on Christmas to make sure everyone gets what they're looking for. And we need to make sure that when using the system, people experience the joy of the holidays. Look at this list. It really ties nicely into e-commerce. You have user profiles, wish lists, product information management or PIM, inventory system, carts and orders. And of course, you need some unique front ends, whether that's a website, a mobile application, etc., which ties perfectly into composable commerce. Really, the only thing you don't need is payments because, Santa does everything out of the goodwill of his heart rather than expecting us to pay for it. But more than e-commerce, we're looking at a really large-scale system. We're looking at 8 billion users. They're active all year round, but a massive surge takes place in December. We're looking at all of the fulfillment happening in a single night. So this is a true high-throughput system. We have users across the world. It's a global distributed system. Every possible language, every possible locale is coming into play, which means we also have to deal with security compliance across the world, GDPR, ADPPA, etc. And of course, it's not going to be truly magical unless it's fully accessible. So accessibility requirements are really important. And these tie nicely to other large-scale systems that I've dealt with. So when dealing with building these high-scale, high-throughput applications, one of the most important things to do is to deal with architecture. So it's important to bring in an architect, a dedicated architect for the project from day one. And that, architect will come in and affect those architecture decisions. They'll impact the project and development. And it's important since choosing the wrong design can create lock-in, an inability to scale, or even project failure. So step one is to have an architect in there from day one. And that's the part we're going to play in this project, is architecting the system and making sure we're pulling in all the right pieces. The other thing we need to think about is that this is truly a large sales system. This is bigger than any application out there, considering that Santa works with every single person on the planet and can do all of these deliveries in one day. So while programmers can make a Twitter clone in a 2-day hackathon, there's a reason why Twitter had so many fail whales in the beginning, as its user base grew faster than the system could be scaled, because scaling is important to bake in from day one. And we, of course, have a short time frame to make this happen, but we also need to think about scalability in every step of the path. So let's talk about what scalability means and how it works. Let's come up with a weird hypothetical. Myself and some friends, we want to go watch the Christmas tree lighting. It's too far to walk, so I say, hey, no problem. We can fit in my car. I'll drive us all over there. But as people catch word that we're going to this Christmas tree lighting, more and more want to come. And we won't fit all in one car. So we need to think about how we deal with this situation. This is scaling in a nutshell. too many users, not enough capacity. So one option is we just tell all the extra folks to leave. Basically say, sorry, you don't fit. And this is paramount to sending back an error from your system where you say, hey, I can't handle all this capacity. I'm just going to start throwing back errors to the end user. And this is a terrible experience. It's something that Santa would never deal with. So another option might be to just say, hey, let's deal with it in 2 trips. So rather than doing 1 trip, I'll just drive everyone there and then I'll drive back and drive the next group over. And this actually does have parallels to e-commerce and to websites in general, in that people have adopted this idea of a waiting room where customers get into the waiting room and they have a countdown and they're waiting for their turn to make their purchase or to have their transaction. And companies do this to minimize issues at peak volume and during these massive traffic spikes, unexpected spikes. Anyone who tried to get Taylor Swift tickets recently knows exactly what this is about. But it is not a great experience. You're sitting there waiting when you really just want to transact, get out, and move on with your life. So the first good option we have is to just scale up to meet this new demand. In this case, my friend John has a van. He says, hey, we can use my van instead of your car and we can all fit in. Great. We're scaling to meet that demand. And as the group of people gets larger, we are just going to bring bigger and bigger vehicles. We're going to go to a van, to a bus, to a train, etc., to handle that increased capacity. And this is exactly what vertical scaling is. As you have more people, you scale up your vehicle or your infrastructure. And it's the easiest and most common way to scale a system. You can add better hardware or just, dial things up on the cloud by adding capacity, adding more processing power, whether that's storage, CPU, memory, or other resources. And it may be the best option depending on the task you have at hand. Specifically, things like CPU-bound calculations, it makes sense to scale vertically by just adding more CPU capacity. It is worth noting, though, that even with the cloud in place, vertical scaling has clear limits. At some point, you just can't get bigger. At some point, you just can't scale up vertically anymore. So what do? Well, let's go back to that example where we're trying to make it to the Christmas tree. So maybe instead of adding a bigger vehicle as the group gets too large, we instead rethink things and say, hey, let's just add more cars. Rather than having 1 car make a trip, we can add 2 cars. And as the group number of people goes up, as the group gets larger, we add more and more cars to the mix. And this is horizontal scaling, where instead of beefing up that one hardware component, we're adding more hardware components to the mix or more cloud resources to the mix. So this definitely helps us to scale even further for more people. Although it does come with some drawbacks. It comes with increased complexity and costs, the ability to auto-scale by adding additional servers and containers can mean re-architecting the entire solution to deal with having multiple servers. But it does have some benefits as well, that it can be leveraged on layered onto an existing system with zero downtime because you can just add and remove horizontal scaling as necessary. It also has high built-in availability and fault tolerance. And for certain tasks, it is the best option. It is worth calling out that when you program this application, you need to know whether you're going to horizontally scale it or not, because it does limit the use of things like server sessions, application cache, and other features where you can't use them out of the box. You either need to design them for this horizontal scaling, or more likely, you need to build your application as a fully stateless design where users can bounce from server to server. Because while load balancers say they can keep your user on a specific server, it's best not to rely on this functionality and to assume that they're going to be bouncing around as servers come online or come offline, etc. So for this application, we're going to need both. We're going to need horizontal and vertical scaling. After all, this is Santa's tech stack. So one of the complaints or comments I will often hear when I talk about building these applications for scaling is, why do we need to think about this? Just use the cloud. The cloud can auto scale by default. But that's not as simple as it sounds. So for one thing, while cloud offerings do offer certain managed solutions that'll auto scale, these often cost more, and they definitely create lock-in to that specific cloud service. And for this example, we might need redundancy between clouds. Maybe we want to host on AWS, GCP, and Azure. Also, data residency laws may prohibit certain cloud options. So, if we want to be in China, as an example, we might not be able to use a certain cloud there. So instead, we really want to be focused on using industry standard tools. So using things that are cross-cloud. And these tend to gravitate towards open source. Another thing I want to talk about in terms of scaling is partitioning. So while you can scale up a single system, sometimes it makes sense to look at the logical bounds of that system and break up our application into pieces as it makes sense. We talked about data residency laws and preventing certain cloud usage. Well, maybe we want to actually have multiple instances for each different locale that we're going to be in. So Europe can have its own instance, North American instance, and so on, in order to both handle the scaling requirements, but this also handles the logical requirement of data residency laws and other business needs. So it does make sense to look at the business requirements and ask ourselves, is there a way to break this up logically where it helps the business and it helps meet our requirements, and it means that we're not having to scale up one application nearly as much. Instead, we're splitting it across multiple applications, which, this conversation on partitioning actually leads to the next section, which is breaking things up. Any really large, complex problem is overwhelming and impossible to solve in one go. So the best thing to do is to break this up. And actually, the first place to start will be to breaking up the teams. I think at this point, we've all heard about the 2-pizza rule for meetings, or the old adage that 9 women can't make a baby in a month. This actually comes back to Brooks' Law. It states that adding manpower to a software project, especially one that's behind schedule, will delay it even longer. And this was coined by, Fred Brooks in his 1975 book, The Mythical Man Month. So under certain conditions, an additional person, when added to a project, ends up taking more time rather than less. So why is that? Because it takes time for people added to a project to become productive, that ramp up time. But also software projects are complex engineering endeavors. And new workers on the project need to become educated about what we're building and what's come before and what the plan is coming after. And by that, it's important to break up teams and to realize our teams, at the beginning of the project, and not just try and layer on people as we go to speed things up. So Santa was kind enough to give us access to all of his elves, right? So we have a great number of elves to help us out here, but our best bet, rather than just saying, hey, we've identified the project, we've identified the requirements, is to first take those elves and split them up into specific teams. And once we have these teams split up, into smaller groups that are more manageable, we can give each team an individual project. And to do that, we need to look at the larger project and we need to break it up into logical, distinct functions. So when we do this, it's very important to be clear where we draw the boundaries. We really need to be experts in the scope of what we're building. We need to really be experts in how it works and how those lines can be drawn, because otherwise there's too much interdependency between teams. We want them to be able to run quickly without constantly waiting for blockers from other teams. Thankfully, in the e-commerce space, this has become very well known. So we know that we can break this up into distinct pieces like user profile, wish list, product information, search, and so on. So we can take all of those teams and give each one a different piece of the puzzle and make sure that they're not tightly coupled. The other nice thing about breaking people up into these teams is that each team can have full ownership and autonomy over what they're building. They can become experts in their space. Not only can they become experts in what they build, but they can be the ones to run it, they can be the ones to own it, and they can innovate in their specific domain. And I'm sure you've all heard this before. It's been popularized by many large companies, and it's actually the first tenet of building a microservices application. So, microservices. A microservices architecture consists of a collection of small, autonomous services. Each service is self-contained and should implement a single business capability. Sounds a lot like how we broke up their teams. So since we have our teams broken up, we have our project broken up, why not also break out the deployment into these microservices? So characteristics of a microservice. They're going to be small, independent, and very loosely coupled. So each service should have a separate code base. They should be deployed independently. They should be responsible for persisting their own data in their own external state. They can communicate with each other over well-defined APIs. And they don't need to share the same technology stack, libraries, or frameworks. Although that's often helpful in a single company to have that sharing, it's not required. And as we just talked about, they're going to be owned by a small team. So I'm sure everyone's heard about microservices. It's been the buzzword of the day for a while now, but it is a very useful pattern. So instead of drilling in microservices again one more time, I'll let you go search some of the many great videos out there about microservices, even some on the Elastic Path channel. Instead, I'll dive into microservices anti-patterns, things that we've seen that you shouldn't be doing, things that can make it so your microservices, implementation fails, or more importantly, things that people run into, which then make them go out on the web and write articles about how bad microservices are and how you should avoid them at all costs. It's because they probably hit one of these anti-patterns that takes away the value of microservices. The first one is assuming it's just tech. When people hear microservices, they're like, oh, okay, this is a architectural approach. No, it's a way of thinking. So team structure is equally important. If you have one giant team and they're all just working on the microservices willy-nilly, it's not really going to work out for you. Also, if you treat your team as resources where they bounce around from service to service, they're going to get frustrated because they're constantly learning new applications, maybe even new code bases. And it's going to be exhausting to constantly get up to speed on the next project they work on. No, instead they should be broken into teams, and each team should be responsible for their service so they can become experts of that service. This is the first tenet of microservices, and it's extremely important, and it's so often ignored. The next one is sharing a database. Oftentimes people will build out microservices where the services are that compute layer, and they're all calling back to a single database. And this is definitely an anti-pattern. This creates a single dependency. Even if they're not sharing data in the database, although they often are, you're still ending up with that single dependency that prevents microservices being independently deployed and independently worked on. And then if you have, let's say, a database upgrade where you need to apply patches, you might end up having to patch every microservice at once, and you're creating these awful dependencies across them. So, as mentioned earlier, microservices need to own their own state. They need to own their own data. If you're working with microservices that share a database or connect to the same database, you have an anti-pattern. You're creating something that's a pinch point and destined to fail. Next up is a layered service architecture. But this is about microservices calling microservices. So, you need to be sure that your teams can work and deploy independently of other teams. And I think this happens when people get too caught up in the word micro of microservices. And then I've seen articles out there like, don't use microservices, use mini services instead. Or, use small services or whatever we're going to call them. Because programmers hear microservices and they immediately bring it back to code. And they go, well, in code, the small piece of my application is a function. So each microservices should be a function, and I'll just have lots of functions. But instead of in code, they're in services. No, they're not functions. They're not equivalent to anything you've been doing in code. They are specific business capabilities. You're breaking it up based on the business needs, not based on how you write software. So each service is going to have multiple functions or classes or whatever, paradigm you decide to go with when you start programming this. So don't think about mapping your services back to your code. You need to map your services back to your business functions. Next up, a lack of internal versioning. Okay. So often these microservices get stitched together into a final API. And that API is going to have your API contract, whether that's an open API spec or a GraphQL, endpoint. And I see that final endpoint, that final API has a version number for it so that you know which version you're on. But the internal services do not. That's a serious problem. Each microservice should have its own versioning, so that as you deploy things, whether you're doing canary deployments or blue-green deployments, you know which service is where. But also just so you're keeping track of each application, because again, they're breaking it up into separate applications and you need your applications to have version numbers. So while you might have an API contract with a version, you need to have your separate services to have one as well. Last one, lack of automation. And this is big. I see people get into microservices and they're building things out manually and they're wondering why it's so hard. And it's hard because building out your infrastructure, your cloud infrastructure, your containers manually is a time-consuming process. I couldn't imagine having to go into a UI and click all the buttons every time I want to update a microservice. That's definitely going to slow it down and it's going to take away the real benefit. And it's no surprise that microservices became popular at the same time that all these other tools became popular, where DevOps came out and we had CI/CD pipelines and monitoring, container orchestration, and more. It's because those infrastructure tools are what made microservices an attractive option. If those didn't exist, then it wouldn't be an attractive option and we'd all still be building monoliths. So I think it's important, if you're not going to adopt these best practices, like having a CI/CD pipeline that's automated for your developers, or using DevOps to put your infrastructure as code, then don't go down the road of microservices. You're going to be in a world of hurt. So I talked a lot about the conceptual concept of microservices, but what if you want to get going on building your own stack and using them? What are some tools that are worth looking into? Well, these are just an example of open source options that are definitely popular in the space. They're leading the way. There are more out there. And when I gave this talk in person, a bunch of people, raised their hands and gave their favorites in the space. So this is not an exhaustive list, but it's a good place to get going, a good place to start Googling and learning about the tools you might be using in this architecture. The first one is GitLab. GitLab is going to host our code repository, but also it's going to have things like their CI/CD pipeline, where GitLab has their own actions and they have their own build tools that can help you with that automation. So GitLab, a great open source option. Another option out there in the space would be GitHub, that everyone's familiar with. The next icon is Terraform. So Terraform is going to allow us to manage all of our cloud infrastructure that we're using to run these services in code itself. And then we can take that code and check it into GitLab so we can track it and we can automate the building and managing of that cloud infrastructure and we can know exactly what's going on. So this is extremely important as you have multiple people working on it, but also, we talked about spinning up additional instances in different regions. Well, if you have a Terraform provider, you don't have to know how to do that. You can just run the Terraform script. Whereas if you're doing everything manually by hand in, let's say, the AWS panel, now you have to try and reproduce it and make sure you got it right every time when you're trying to stand up an instance. The next icon is Helm. Helm is going to allow us to manage all the different services, define, install, and even upgrade specific services within our Kubernetes instance. And I think I actually skipped Kubernetes there in between Terraform and Helm. Kubernetes, I think everyone's familiar with. It is a leading way to run all of our different services. We're going to run those containers. It's container orchestration. Docker, I think everyone's familiar with Docker. It's the leader for containers, although there are now additional standard options for building these containers. So, go out there and make sure you're containerizing your services. And then finally, that last one on there is Kong. Kong is actually an open source solution that you can install in Kubernetes that gives you all the great things that you probably want anyway, like an API gateway, security logging, rate limiting. It even allows you to do things like serverless functions that are hosted within Kubernetes. So it's a great place to get started to kind of fill out what you're missing in setting up this architecture. So let's start looking at some diagrams. So we have our different services. So we have our user service, product service, order services, and so on. We're probably going to put all of those behind the API gateway. The API gateway is going to decouple the client from the services. So we're going to have multiple clients here, whether that's a website, a mobile application, etc. And these services, they can be versioned, refactored, upgraded, all independently of the client, which is super nice. And you'll notice that they can be balanced the way they need to. So the user service might need 3 compute instances and 1 database, where the product service, we might need to be sharding that database and scaling that up, but not necessarily the services, and so on. And all this running in Kubernetes, where we can have multiple instances of Kubernetes running across the world. So, talk about the client. Let's dive in a bit on that front end and how we should build out the client. Because let's be honest, we can't ask our users to call our microservices directly through Postman or some other tool. No, we need a really good front end for people to interact with. And yes, we can ask them to physically mail in things like wish lists to Santa, but then we have to open it and input it into the system ourselves. So we still need a front end. Plus, it's 2022. There are plenty of places where you can email your wish list to Santa. Or in this case, I think the most popular option is to build a website, one that can run across multiple devices. And when it comes to building websites, a lot of people have this conversation of, should we build a traditional server-rendered website, something that's been well known with server-side languages like PHP, Ruby on Rails, etc. Or should we go down a more modern path of single-page applications, whether it's browser-rendered, built in JavaScript? And from what I can see, the debate is over. All the new projects I'm looking at are people moving towards a JavaScript-rendered front end. That's the direction everyone is going into. What I think is interesting, though, is that they were never meant for the same purpose. Traditional server-rendered website, it's a website. It's really good for content-heavy sites. Think of something like Wikipedia, where people are entering in any page and they want it to load quickly and they just want to read their data and move on with their lives. Whereas a single-page application, it's in the name. It's an application. It was built for things like Gmail or Sheets or other online applications where you have a single entry point. You're probably going to spend all day in that application. So you're not entering from any page. You're not worrying about that load time, because once the application is loading, you're just clicking around within it. And it's, geared towards a very interactive experience. So it is interesting that a lot of people have moved towards these SPAs for handling their website needs. And what's great is there's been this new wave of SPA frameworks that have adopted to these new requirements and these new needs. They've moved away from the application, and they're going more towards a transitional design or transitional app where it can switch between server rendered and client rendered, and it can do things that old SPAs couldn't do. And if you're looking to move down that route, definitely check out things like Next.js 12 or anything past 12, which is what the Elastic Path D2C starter kit is built on. But also SvelteKit, Remix, Solid, and more. They're all taking ideas from server-rendered websites, saying the best of server-rendered and adding it to the best of SPAs and making something that can transition between the two depending on your specific needs. So I think that's where our front end is going. But let's talk specifically about building out this front end. Because one of the difficult things about microservices that no one talks about is you need to stitch it all back together somewhere, specifically on the front end. You need to bring it all back into one unified experience. So here's a classic product page where we might be pulling data from different places. We might be pulling down some product information from our product service, but then also maybe we have an image service to get our images from, and also an inventory service to pull that in stock flag out and get that data there. So one approach is to go ahead and make all of these separate calls directly from the browser, directly from the product page in our SPA. And this seems to work pretty well. I mean, after all, SPAs are meant to make a bunch of API calls. But as you continue to grow and build the application, you start to run into some possible issues. You know, a more complex page would be a search results page or a category page where we have lots and lots of products. And what if our requirement says, hey, I really liked that in stock flag that you had from the product page. Can we add it to the gallery page as well? And now you say, well, hold on, there's 15 products on the page. In fact, the user might be able to choose how many products they see. I can't add 15 to 100 plus inventory calls as you go through the product list. I can't add it right to my, product module in my code. So you start to think, well, maybe I can go up to the parent component, and as I get the list of products, I can call it there, or maybe the inventory component can give me a list of items rather than calling it once per each entry. But that's really complicating your code. It's really complicating your SPA, and it's asking you to change the service to meet the front end requirements, which is not usually a good practice. You want to build the service based on a well thought out design. So that's what leads us to Backend for Frontend, where we're going to put something in between our microservices that help with things like aggregation or custom front-end business logic or abstracting the APIs to streamline our front-end code. So that's considered a back-end for front-end design, and it's becoming more and more popular. And I want to call out that a lot of times when you talk about back-end for front-end, GraphQL fans quickly pull out that, hey, GraphQL makes a great aggregation service. In fact, I didn't have to build this slide because I took this slide from a previous talk that I had done about GraphQL. So GraphQL is often proposed as this middle aggregation service between all of your endpoints. And honestly, I think this is a great solution for small projects. If you're building a small project, I think GraphQL as an aggregation service can certainly work. It automates a lot of stuff for you. It's a great path to go down. But this isn't a small project. We're talking about the scale of Santa. So why wouldn't I use it for large scale or enterprise projects? Well, let's look at some of the GraphQL pain points. This is directly out of the State of GraphQL report. And you see that the biggest issues with GraphQL, they're error handling, performance, caching, and security. These are all major concerns for a large-scale system, and they are not easy to deal with when you're hosting a GraphQL server. So we spent all of this time designing a system that scales horizontally and vertically and building it with microservices and worrying about ensuring that we build a huge system that can handle our capacity. And the last thing we want to do is put a single point of failure in the flow that is known for performance issues. We don't want one single point of failure there, and we definitely don't want one that's known for having these issues of performance and caching and security. That seems counterintuitive to everything we're trying to build. So while GraphQL comes with a lot of benefits, those benefits tend to be developer productivity in nature. Things like type checking or introspection or so on. So that developer productivity is great, but you can now get that developer productivity out of a REST API if you just use an open API spec. So also known as Swagger. These open API specs give you a lot of great features that can help you with that developer productivity. So if you write the spec first, it gives you a proper API design. So rather than letting your code dictate what your REST API looks like, you're writing the specification so that it's a clean, proper design, and you're not seeing the underlying implementation in the API itself. That's called an API first approach. But once you have that specification, it gives you something very similar to GraphQL's introspection, where it outlines that full interface. And it can also be used to generate docs, generate SDKs, generate interfaces, and more. So it's doing a lot of that generation that you get from that introspection as well. And better still, you now have a way to track what's going on with your API. You can check this specification in. You can check what happens from version to version, update to update. And there's toolings that you can put in your CI/CD funnel that will help you understand as your open API document changes, is this a breaking change? Should we allow this? Does this make a major version, minor version, or is it transparent where it's an underlying patch that doesn't actually affect the surface layer of your API? So you're getting all that developer tooling with REST by going at it with this approach. And you're also getting something that's well known, that's been out for decades. It's easy to scale, easy to cache, and has an amazing ecosystem. So for any large scale application or anything you think might get large scale, I would definitely use a REST API instead of GraphQL. If you're doing something small where you need to run fast and you're familiar with GraphQL, go with that. But here we're talking about Sana's tech stack, so we're going to pick GraphQL as our option. But hey, if we're not using GraphQL as the middle layer, I went through that whole diatribe of why not. Well, how do we build that BFF and where do we put it? Well, in past projects, I've actually been tasked with putting that BFF layer within Kubernetes itself. You might put it in the same Kubernetes cluster. You might put it in a whole separate cluster itself. And you build them as services, the same way you would build your backend services. And this worked. It definitely gives you the same scaling and performance and other benefits that our microservices do. But it does add a lot of complexity, and it means that your front-end team either needs to work with back-end devs or they need to become experts themselves on both sides of the equation, which is a lot to ask for one developer. So it would be ideal if instead of putting it within Kubernetes or in some separate system itself, like I've seen people try serverless functions, but that creates lock-in and additional DevOps, would be to put it with the front end itself, to keep it with that JavaScript code. And what's really great is these new JavaScript frameworks allow you to do that. They allow you to write back-end code in different ways, which then creates your BFF layer. So looking at Next.js, they have a concept of API routes where you can build API routes directly into your project, and then you can deploy them to the cloud. You can deploy them with the rest of the application. And the same way you're going to do server rendering, you're getting now API routes, which are fully server-side applications. Nuxt.js does not have it built in by default, but they do have this option called a server middleware. And with that server middleware, you can actually create API routes yourself. It's a little more code than the Next.js example, but it's definitely possible with Nuxt.js to build your APIs directly in with your code, and you're using Express to do it. And then SvelteKit has probably the easiest way to do it, where you just have to create a plus server file within SvelteKit, and now you've got a server-side API route that you can run with, which is great. And the other modern frameworks have this as well. So whether you're looking at Solid, Astro, etc., they all have this hybrid approach to building websites where you have server-rendered code, server-rendered API routes, then you have browser-rendered code, and you can call those API routes as necessary. But what's even cooler about these options is you're not just deploying it to a Node.js server. You can actually take these really light JavaScript APIs, because again, it's a BFF layer. You don't have to worry about data storage or other complexities. So you can take these light JavaScript pieces of code and you can deploy them to a CDN as edge functions and take advantage of edge computing. And here's AWS's map of all of their edge locations. So these functions can be deployed to, whether it's a Lambda edge or one of the other edge services like Fastly, AWS, Vercel, Netlify, and more. And these edge services have benefits over a traditional serverless function in that they don't have cold starts, but they can definitely auto scale as necessary. They're deployed globally to handle our global application, and they can really improve the performance of our final solution. In fact, here is a graph that I pulled together comparing a traditional AWS Lambda versus edge functions. So I called the API, 10 times from each region, and here's the different response times that I got out of each and every one. And if you want to find that article, it's available on dev.to, and you can see the methodology that I used to deploy it and to test it and to see this huge performance gain by deploying it out onto the edge instead of using traditional server. Oh, it sounds like we have some breaking news coming in. Yes, our project conditions have changed. Santa's giving me a report right now that he's been reviewing the data that's been coming in. And unfortunately, the most popular year's gift has changed. It's no longer what it was, but it is now any type of JavaScript monster, whether it's toys or stickers and so on. It seems the popularity of the language has made these a hot commodity. And he needs to repurpose the elves into building these to make sure that they're available for Christmas. But he said, don't worry. He has reassigned his reindeer and the abominable snow monster to take over. So they're going to help us with this project. Oh, but I'm hearing now that unfortunately, all of these new team members are only front-end developers. They have no back-end experience. They have no DevOps experience. So we need to redesign our application with no back-end developers at hand. This seems challenging. Oh, but I'm also hearing that he has increased our budget. Okay, so API SaaS to the rescue. Let's use some SaaS companies, some API first ones specifically, to save the day. So instead of building these, completely separate and hosted options, the user service, product service, order service, etc., we are now going to buy SaaS functions to take care of it for us. So for content, we might use something like Strapi or Builder.io. For search, Elasticsearch, Algolia, Constructor, etc. And of course, for all of our commerce needs, whether it's our great PIM for products or our cart, checkout, wish lists, etc., we will use Elastic Path for hosting that data. So we're going to take advantage of the fact that these SaaS companies have already done the heavy lifting and instead just use them to build out our Santa's tech stack. So thank you. That is my talk on Santa's tech stack. If you want to learn more, I'm available on LinkedIn. Please reach out and connect, or find Elastic Path, our blog, our YouTube, or just elasticpath.com to set up a free trial and start playing with this new way of building applications. I want to thank you for letting me speak today. Hopefully everyone got to learn something and got a new tech that they can start researching and implementing in the new year. Thank you very much, everyone, and have happy holidays. Appreciate it.